Hello and welcome back. Now we are still on algebraic expressions. In this video we're going to be learning about simplifying algebraic fractions. I have a couple of examples that I want you to check out and see how I'll be doing it, so that you may also be able to do the same in the problems that I'll be giving you. Simplify the following. On part A, what we have is 4a squared b divided by 10ab squared. And on part B we have xy squared plus xy divided by 5x plus x squared. Right, so let's go on to the solution. I want you to pay attention. Maybe have your pen and paper ready. Okay, so for part A, where we have 4a squared b divided by 10ab squared, what you do is you look for the highest common factor for both the numerator and the denominator. I'm seeing here that the HCF with our 4a squared b and 10ab squared on the denominator should come out as 2 for the numbers, and for the terms in a, that's a, and for the terms in b, that's b. That should be our HCF. And once we have the HCF, the highest common factor, we divide both the numerator and the denominator by that HCF, which is 2ab. If we now divide the numerator by 2ab, what we get is 2a, right? And if we divide the denominator by 2ab, remember 2 into 10, that's 5, so we get 5. A and a will cancel out. B into b squared will be b, so we get 5b. Right, so that simply means that the solution will come out as 2a over 5b, and that's the answer to part A. As simple as that. Alright, so that's part A for us. Let's move on to part B, where we have xy squared plus xy divided by 5x plus x squared. Looking at this one, we may look for the HCF, but in this case I want to do it in such a way that we factorize both the numerator and the denominator. So we first look for the HCF for the numerator, where we have xy squared plus xy. And I'm seeing here that the highest common factor for those two algebraic terms will be xy. So if we factor out xy, dividing xy into xy squared, we get y, and dividing xy into xy, we get plus 1. So that's the numerator for us. And for the denominator, where we have 5x plus x squared, the HCF right there, highest common factor for 5x and x squared, is x. And if we factor out x, what we get will be 5 plus x inside the bracket. So we have completely factorized both the numerator and the denominator, and now it's now easier for us to simplify, because I'm seeing here that if we can cancel out x on the numerator and x on the denominator, such that we'll be left with y of y plus 1 divided by 5 plus x, and this will be our algebraic expression simplified. Sorry, algebraic fraction simplified. I don't think it will go any further. So that will be our solution for part B. You can simplify the numerator of the bracket to get y squared plus y if you want, but even this way the solution is okay. So that's our example 1. Now I have another example, which is example 2, and with example 2, what I want is also you to see how I'll be working the type that I have here, the type of algebraic fraction expressions, how to simplify them. And then once you learn, then I'll be giving you some examples for you to work by yourself. On part A, we want to simplify 2m squared minus mn divided by an minus 2am, and on part B we have p squared minus 2pq plus q squared divided by 2p squared minus 2pq. Solution. Starting with part A, 2m squared minus mn divided by an minus 2am. If you can recall what I told you in the previous example, we said you first factorize both the numerator and the denominator to see if there's any chance to cancel out some terms and simplify your fraction. on the numerator where we have 2m squared minus mn, the HCF right there is actually m. So we factor out m and divide m into 2m squared, we get 2m, right? Into 2m squared we get 2m, and we divide m into minus mn. What do we get? We get minus n. So that's our numerator factorized. We go on to the denominator where we have the common factor right there for an and 2am. I'm saying that the highest common factor is a. Factoring out a, we'll be getting n minus 2m in the denominator right there. So that is what we have right here. Alright, so I want you to notice something. We have our 2m minus n on the numerator, and we have n minus 2m on the denominator. These two values are different but not too far from each other, because you need to understand that once you have such a situation where you have your a minus b divided by b minus a, what you need to know is that the solution will always come out as -1. This is a very important thing for you to always understand. Wherever you have got your terms a minus b dividing b minus a, or b minus a divided by a minus b, dividing those terms will always give you a -1. How is that so? I want you to see here that if you have your a minus b, if you factor out a -1, then dividing -1 into a, you get -a, right? Let me just put it right here. You get your -a, and if you divide -1 into -b, you get positive b. I'm just gonna rearrange, put it like this, and you see if you divide by your b minus a, you are going to cancel out the b minus a, and your solution will eventually come out as -1. So always remember that. Alright, so if that is okay, then with this one that we have, where we have 2m minus n divided by n minus 2m, is that same form again. If we divide 2m minus n into n minus 2m, what we're gonna get is -1, right? So that means our solution will come out as minus m over a. That's the answer. That's the solution to part A. Very, very important things here in this question. Okay, and let's go on to the last one, part B, where we have a quadratic p squared minus 2pq plus q squared divided by 2p squared minus 2pq. Right, so what do we do on this one? You can see here that we said we factorized both the numerator and the denominator, but the numerator is a quadratic expression that needs to be factorized in the using the methods we talked about when we were on the topic of quadratic expressions. We're also going to be having videos on algebraic expressions and factorization in this course, so I want you to check them out again to see how we factorize quadratic expressions. But for p squared minus 2pq plus q squared, that's a perfect square. So if we factorize it, then what we get right there is p minus q, p minus q. It's a perfect square, right? So don't worry about this if you do not yet know how to factorize this one, because we're going to be covering that very soon. So that's our numerator factorized, and on the denominator, the factor, highest common factor for 2p squared and minus 2pq is 2p. So we factor out 2p and we divide 2p into 2p squared, and what we get is p, and again we divide 2p into minus 2pq, and we get minus q for the answer. And here I'm saying that we can simplify further here, because I'm saying that we can cancel out, divide p minus q into p minus q, we get 1 right there and 1, and we are left with p minus q over 2p, and this becomes the solution to part B. Right, so I've talked about some very important things in this video. I'd want you to play it back so that you may really have a grasp on each and every concept that I've covered in simplifying algebraic fractions.